The 8-phased array antennas can be configured as transmitters and receivers. The router then does a scan of the area based on the configuration using beamforming. The router extracts CSI information from the received signals. The data is then processed by a fingerprinting algorithm to identify potential locations of interest based on the channel knowledge map and confidence matrix. The router then focuses the beam in that area to try to identify location of the person. There are 4 graphs that visualizes the CSI phase and magnitude data. 2 polar coordinates on the left shows the current and average CSI phase and magnitude in polar coordinate system, where the phase of the incoming signal is represented by r and the magnitude is represented by theta. 2 heat maps on the right shows the current and average magnitude of the received signal per antenna. At beginning, the magnitude data settles down around a base level, as you can clearly see in the current magnitude data heat map. But it starts to fluctuate as soon as there is movement in the channel, as clearly visible in the current magnitude data heat map. The magnitude data settles down again when movement is stopped. The average magnitude data does not fluctuate that much over time, thus providing baseline readings to accommodate dynamic environments. The current CSI data appears to be almost random due to reflections in the room. But when we look at the average CSI data, we can clearly see that it converges towards the wavefront, which is almost perpendicular to the antenna due to being reflected by the opposite wall of the lab. Without using any machine learning model, we can very easily detect movement in the channel. This demonstrates the benefits of using massive MIMO system and the sensitivity of 60 GHz signals towards any living targets and changes in channel. The average magnitude provides baseline readings, while the current magnitude provides information about any instantaneous changes in the channel. These readings will become the base for the machine learning model. The machine learning model will create a channel knowledge map based on the CSI data and a time-dependent confidence matrix based on the last beam sweep of the environment. This allows us to create dynamic baseline readings and thus helping in easy identification of the region where a person might be present.